So my name is Kristen Yu, and I'm going to be giving a short talk about video game development. So just a quick about me. I am a PhD student at the University of Alberta, and I work on video games and AI for my research project. I'm also currently collaborating with a video game development company called Improbable. They are a studio here in Edmonton, and they are considered a AA development house and not a AAA development house. But it's very exciting because I get to actually work on developing a game. And I'm also originally from California. Edmonton is very cold to me, and this is actually a picture of my hometown. So the first thing I want to talk to you guys about are some video game development engines. Video game development is a little bit different than other kinds of development because it's not necessarily just dependent on a language, but also about what kind of engine you want to use to build your game. The first one I want to talk about is RPG Maker. So this is what I would recommend if you are interested in doing video games, but you don't have a lot of programming experience beforehand. As the name suggests, it very easily helps you make an RPG, but there are a lot of tools and plugins that allow you to make other kinds of games like platformer, for example. So for RPG Maker, it's low levels of coding. If you do choose to do coding, it's in JavaScript, which is a pretty easy language to learn. And even though this is a more simple engine, it actually is used at the U of A as part of our game development courses. So just because it is the simplest or easiest to learn approach doesn't mean that it isn't worth learning. The next one I want to talk about is Unity. This is my personal favorite game development engine, but again, there are a lot, so that's just my own bias. In order to program in Unity, you use C#, so that's similar to Java, if you guys are familiar with that language. And it's a favorite of independent developers. So Supergiant Games, they make Bastion and Hades, the new big one, Transistor. They use Unity, and it's there's a lot of different games that use Unity. So this is some examples of what can be done with this particular game engine. The last one I want to talk about is Unreal. So Unreal is the favorite engine as in the industry. So this is actually the game development engine that we use at Improbable, and it's also used in a lot of different studios basically around the world. This has the highest learning curve, so if you are new to game development, then I would recommend that you try one of these other two before that. However, if you already kind of have your foot in the door and are looking at expanding your skill set and trying to look at what is next, you can try to learn Unreal. Unreal uses C++, so if you already know C++, that could be a little bit of an advantage, but that's not necessarily a requirement for programming in Unreal. So now I want to talk about a game that I've actually developed. This is a little demo that I made at a game jam, so that was just over 3 days, and it's called Back Home Bots. The basic idea is that you are a little robot and you crash landed on a planet, and now you're trying to get home. So this link in the corner is how you can actually play the game if you guys decide you want to. But basically, when you make a game, there are a couple of things you have to consider. So the first thing is what kind of game you want to make. So this game is a puzzle game. As you can see, you want to get your robots to these little escape pods in the corner. However, you have to make sure that each robot gets to the escape pod correctly. So you have to puzzle out, or you're challenged to figure out how to get your bots in the correct configuration in order to beat the level. So this is just another, there's only 2 levels in the game, so this is the other level. And so this is just walking through some of the decisions that we made for design. So as you can see, the interesting thing about this game is every single time you choose a movement, you actually move 2 tiles and not 1. So that's a kind of unique concept that this game had and allows us to make more complex puzzles. So when you're actually making a game, there are 2 things that you guys would probably want to consider. The first of these is the actual game design. So game design refers to all the decisions that you make in a game to actually, kind of make it a game. So if we take this level, for example, the first thing we need to consider is what is the final configuration of bots going to look like? We want this to be a puzzle, so we don't want it to be easy, right? The next thing you want to do is consider where the initial placement of all your bots are going to be. So that can also provide challenge because as you can see, this one in the middle that's kind of surrounded by holes or obstacles, that provides a little bit of challenge because it forces your bots into a specific configuration to go get that bot, and then you have to untangle yourself from that configuration in order to actually solve the final level. The other thing that you want to consider are these obstacles. So these obstacles are really cool because they serve a dual purpose. The first one is to get in the way. They can make it more challenging to actually make your configurations that you need to solve the level, but you also need them to actually make the final version, because if you don't have these obstacles in your game, then it's impossible to convince your bots to go to the right the final configuration so that you can actually like solve the level. So those are the game design elements that went into actually like creating this level. The next thing comes to the programming. So the programming is all of the technical work that has to go into building a game. So everything that is functional in the game has to be programmed. So that's the movement of the bots, that's when these bots wake up, that's when the level is completed. It's also when sound effects occur and when animations occur. So that's something to keep in mind if you want to do video game development. It's not just saying, okay, well, I can make my character jump from over a platform. It's also telling the game when to trigger cutscenes, animations, dialogue. All that is considered game programming. So the last thing I just want to leave you guys with is a couple of game jam options. So if you're interested in doing game development, I highly recommend you guys try out game jam. They're basically usually 3 to 5 days where you just decide to start a project and finish it within those 3 to 5 days. The idea behind a game jam is to not say, oh, I have this game idea and I really want to make it. In a game jam, there's always a theme. And so then you're presented with a theme, you have to come up with an idea that fits the theme, and then you can make your game over the course of those games. So it's like a start and stop. That's the cool thing about the game jams. So the first one I want to talk about is Global Game Jam. That is actually the game jam that I made Back Home Bots at, and it's really cool because the entire world, that's why it's called global, participates in this game jam. So they have countries all over the world that are active within this, and we do have a active site here at the so if you guys would be interested, and you can get, and I don't know, COVID is weird, but in future years when you can actually go to site at the U of A and participate in the game jam. I also have 2 YouTube game jams, so Extra Credits channel and the Game Maker's Toolkit channel, which I highly recommend watching some videos if you haven't heard of them already. But they each host game jams over the at different times over the course of the year. And the cool thing about these game jams is you can submit a game, and if the YouTuber likes your game, they'll usually showcase it on their channel for like, 30 seconds. So that's kind of like a cool experience if you guys want to do that. The last one is Unreal Jam. So Unreal, the game engine, sponsors a jam every season. So there's the spring, summer, fall, and winter game jams. The only catch with this one is you do have to use Unreal. So if you're looking to learn Unreal, then this is a really great way to kind of force yourself to learn it. But yeah, I have my email there at the bottom if you guys want to try to contact me, and I have a link to that game that I showcased to you guys so that you can actually download it and play it on your own computers. Unfortunately, it is Windows only, so I apologize to anyone who's using Macs, but if you're interested in trying to solve the second level, you can go ahead and try it out.
Wow, very cool. So I guess we'll move on to the next speaker. If you guys have any more questions, please save them till the end. Does anyone else want to volunteer to go next?
I can go.
Okay.
Is that okay, Chris?
Yeah, no problem. No problem.
Oh, okay, perfect. Let me share my screen. 1 second. Can you guys see my presentation? Is it like in presentation mode?
Yeah.
Okay, thanks, Kristen. So hi everyone. My name is Leticia. I'm actually a master's student at the U of A, not a PhD yet. And right now I'm working in education and language learning, aided by computers in general. But before that, I used to work as a front-end developer during my undergrad and after I finished. So today I'm going to give a brief introduction to app development. So yeah, Web development is basically the building and the maintenance of websites, and it's the work that goes into make websites look good, perform the way we want them to perform, and work fast. And there are a few key concepts to it that I wanted to discuss. The first one is the client. The client in web development is an application with internet access that can load websites. It's usually a browser, and a browser can be an app on your phone, or or on your computer. Examples of browsers are Google Chrome, Safari, Firefox, or Microsoft Edge. The other concept that I want to talk about is the server. The server is a remote computer somewhere in the world that allows your browser to talk to it. So it's often referred to as the cloud, and it could be one or more computers depending on how complicated your program is. Yeah, but how do websites work? We have the client, we have the server. We know that the client talks to the server somehow, and this is usually called a request. So when you're on your computer, you make a request to a server via a browser, and a request could be asking you for a website like Get Me Google, or post a video to YouTube, or like this post on Twitter, like this tweet. And once the server gets that request, it performs an action based on it. So if your request was to like a post, it would add 1 to the number of likes on that post. It would record like this user liked this post at this time. And once the server performs that action, it sends back a response to the client to let the user know that everything's okay. So you would be like, here's google.com, or your video is posted, here's a link to it, or the post is liked. You can see that there's one more like, one more like in the post, So yeah, when you're working with apps in web development, you can work on both sides, and they're different. They're very different, actually. So there's backend development and front-end development. Backend development is usually the programming that involves creating programs that run on servers. So is working with that remote computer, creating programs that receive requests and send responses back. And front-end development is developing programs to the browser. So the client is going to execute your programs, and the user is going to see them. And yeah, so in backend development, you can pretty much use any programming language as long as the language has a way to receive requests and send responses back. So, and when you're working with backend development, you're usually just working with one type of computer. So once you decide like which computer you're using, you can write your program based on that, and that's pretty good. And as I said, as long as the language you decide to use has a way to receive requests and understand how to send responses back, that's great. That's all you need. And actually, that's not all you need. Your language also needs to know how to deal with data storage. So in my example a few slides back, I talked about what happens when you like a post. So when you like a post, you have to somehow store that information. So you have to store that this user liked this post. And that's done with databases. Whenever the server gets a request like that, it adds that information to a database. So whichever language that you're using in backend development, it has to be able to deal with those databases, to deal with data storage. The other side of that, of web development, is front-end development. With front-end development, you have less freedom to choose the language that you want to use, because your program is going to run on all sorts of computers or all sorts of browsers. So there has to be some type of standard so the browsers know what to expect. And that was achieved by using 3 languages, and I'm going to talk about them right now. The first one is HTML. HTML is a language used to display content on websites. So it kind of looks like this. It looks like a text document, to be honest, with just a few extra tags. So you use this language to define what your content is going to be. So for example, in this very short snippet, I have a body, that's my content. I have a header that says Ignite Science, and I have a paragraph with the title of my presentation. So it looks like this on a web browser. It's very raw, like there's only text, and that's HTML's purpose. But if you want to make it look a little bit better, or much better in a lot of cases, you can use another language called CSS. CSS is a styling language that's recognized by browsers, and it lets you style your content. So for example, you can add color, you can add different fonts, you can define where the placement of your content. It also works really well to adapt to different sizes of display. So you want your website to look really good on a laptop and on a phone. So CSS has a set of rules that lets you reorganize your website depending on the size of your display. So for our example, I'm going to change the background color and add a new font family to make it look more like the presentation. And I'm also gonna let the website know that headers need to be bold. So in the end, it looks a little bit like this. So I think it looks better, but anyway, you can style it the way, however you want. And the last language I want to talk about is JavaScript. Sorry. As Kristen mentioned before, JavaScript is a very simple language. And in web development, it is used to add interaction to websites. So far, our website, it only displays content. It doesn't do a lot more, but in like the real world, you want your user to be able to interact with it. And that's what JavaScript does. So right here, I'm going to add a function to my website. And this function is gonna, whenever it's called, whenever the user interacts with it, it's going to add more content to my website. So I added this button. Whenever I click on it, it adds more text to my main paragraph. And yeah, JavaScript makes websites be interactive. This example is super simple, but it's through JavaScript that you actually send requests to the server and get responses back and deal with the responses that you get from it. So you're able to post or, I don't know, get emails and yeah, stuff like that. Yeah, so this was my very, very brief introduction to web development. Thank you guys for listening, and let me know if you have any questions.
Wow, very interesting. I'm sure everyone learned a lot from your presentation. So then would the last speaker like to present?
For sure. All right, can you guys see that?
Yep.
Awesome. Okay, so I'm going to talk about how you can use games to do AI research. Okay, so just a little bit about me first. I'm a second-year PhD student at U Alberta. Before I started grad school, I was working as a software engineer at Intuit on a product called TurboTax. Intuit's a big company that does tax software. And I also worked as a data scientist at a company called Granify, which is a local startup that is trying to use AI to show people discounts when they're online shopping, and the AI system thinks that they're about to leave and not buy anything. So my current interests are kind of about, you know, what happens when you put multiple AIs that are learning from experience into the same environment with each other, and they have to interact with each other. So yeah, before talking about using games to study AI, I should probably talk a little bit about what AI is. And the problem with that is there's, you know, some disagreement on you know, what the definition is, and it can be very broad or very specific. So instead of trying to, you know, give you guys a precise definition or anything, I'll just give you this quote from a guy called John McCarthy that says, "Intelligence is the computational part of the ability to achieve goals in the world." And what I really want to focus on is the thing about achieving goals. So like in this little example of this robot simulator that OpenAI has here, this robot's goal is to walk around this grid and not fall down. It's literally it, right? And it has to learn how to do that. So the reason we want this definition to be so kind of broad and vague is because we want AI to be able to do a lot of different things. Yeah, so games. So I think a lot of people will agree that games are fun. You might like games, but games are also really useful for using AI because they have some specific structure, right? First of all, they have a clear goal. Like, for example, take chess. Your goal is to capture the opponent's king. And if you do that, you win. So it's like very clear what you need to do. And there's also like a well-defined set of rules. So each piece can only move a certain amount, or like move in certain ways. So it kind of limits the possibilities that you have to think about and makes the decision-making problem a little bit simpler. So basically, you know, we use games because the real world is too hard to study at the moment, and we can use games to study specific things and have a sort of controlled environment to do so. So we don't have to stick to games like chess or anything like that. We can look at other interesting aspects of decision making with other games. So the area that I'm kind of interested in most right now is using card games to study certain things. So here I'm going to explain to you guys a simplified version of poker called Coon Poker. It's a two-player game, and it's played with 3 cards: the Jack, King, Queen, and just 1 suit. And so it starts with each player putting $2 into the pot. Your objective is to win money from the other player. So then after they put money in the pot, then each player is dealt a card. But you don't get to see what card your opponent is dealt, and you have to make a decision without knowing that. It's kind of the whole point of the game, right? So in this game, the player who goes first can either bet $1 or check. If they bet $1, and the pot's now $3, and the other player has the option to either call $1 and put another $1 into the pot or fold. So if they call, the pot becomes $4, and then flip the cards over, whoever has the highest card wins. That's it. All right, so in this case, it was probably a bad idea for player 2 to call because they had the worst card. And so instead they could fold, which means they don't put any more money into the pot, but the player 1 still wins it. So the other option for player 1 is to check, which is basically like passing. Don't put any money into the pot, and what did I do there? It becomes the other player's turn. So yeah, so the other player has the option to either bet or check, just like the first player had initially, and it sort of plays out the same way. So if they decide to bet, then player 1 has a choice between either calling or folding and flip over the cards, or they can check, not put any additional money in, and the pot stays as $2 as it was initially, and then we flip over the cards and choose the winner. So hopefully those rules are clear enough. Because now I want to ask you guys, we can use the chat for this, I think, a couple questions about like situations that I think might be a little bit interesting. And you guys can tell me what you would do if you were in this situation. So trying to see if I can see the chat here. Can I see the chat as a presenter?
它有病毒呀。 I think the chat is just like on the bottom. You can see it. Yeah, if anyone like wants to say anything into the chat, that'd be
You
great.
guys, if you have mics, you could unmute and answer. I don't think I can see the chat, unfortunately. I'm not sure why. Like in Zoom.
Chris, it'll like pop up with their answers as they're saying it.
Okay, cool. Okay. So yeah, okay. So you have the king, you're going first. What would you do? Would you bet or check? And don't be shy. You have like at least a 50% chance of getting it right. Oh, there we go. Okay. There we go. Okay, so everybody's saying bet. Yeah, bet, bet, bet. Oh, one person says check. Okay, so this is interesting because yeah, I think betting is the obvious thing to do. You have the highest card, you'll win every time. But the answer is also that you could check up to a third of the time and it would still be optimal. And the reason for that would be that if you check with the king, the opponent might not know that you have the king, and so they might decide that they're going to bet, and then you can get some extra money sometimes. Okay, so this one's kind of tricky, but let's try this one. So you're going second. The first player has already bet $1, and you have the queen. What would you do? Would you call or fold? Okay, I'm seeing a lot of call, which is interesting because the answer is to fold about 2/3 of the time and call a third of the time. And so I think this is illustrating an interesting point that you need to mix it up a lot in this game because if you call every time or if you fold every time, then the opponent can just change the way that they're playing to sort of exploit that. So let's say you fold it every time, because that is like technically a little bit of a better play. If they have the king and they bet and you fold, you're saving some money. But if you fold every time, then they're going to start betting also when they have the jack, and you're just going to fold. So you have to mix it up and call. That's bluffing, basically. You have to mix it up and call their bluff once in a while in order to play optimally, which is why this is interesting. So last one. Again, you're going second. The opponent has checked, and you have the queen. So this one actually has a 100% answer. You should do one or the other, bet or check. Now people are more nervous because it has a right answer, or check. Yeah, you're actually right. You're totally right. It is check, and the reason is if you bet, then it becomes the opponent's turn. And think about what they could do. They either will have the option to call or fold, but they're either going to have the king or the jack. So if they have the king, they're going to call and they're going to beat you and they're going to take your extra dollar. But if they have the jack, they'll just fold and you don't get an extra dollar from them. So there's really no point in betting. So you should just check. So yeah, this is just supposed to be an illustration of why, like, some interesting kind of decision-making situations that these little tiny simple games might pop up in these little tiny games. And the nice thing is we can actually write programs that play these games against themselves and learn how to act in these situations perfectly. So that's all from me, and thanks for listening, guys.
Very, very cool. Okay, then I guess I'll move on to asking some of the questions that the audience has asked. So I'm not sure if all of you guys can answer this question, but what is the difference between computer science, computer engineering, software engineering, and like what's the difference between like the actual courses, the research, and the career? I think Chris can answer this. So do you want to go ahead?
Yeah, sure. So I also did my undergrad at U Alberta as well, so I can definitely answer this So computer engineering is going to be more focused on getting a like programming job or a job related to hardware in industry. You're going to learn like a lot of engineering skills that like kind of like how to build things better, basically, right? Just in terms of software or hardware. And whereas computing science at least should be a little bit more, there's more like theoretical issues in computing that you might want to study, but there's also more options for like kind of what you want to do. So if you want to focus on video game development or something, you can do that in computing science rather than computer engineering. If you want to focus on like theoretical algorithms, you can only do that in computing science. So there's just a little bit more options. If you want to focus on AI, I would say, again, computing science. It's kind of, yeah.
Does anyone have anything to add to that?
Yeah, I mean, I guess I would just say that the computing science degree is definitely going to be more general. So if you don't necessarily know, like you say, oh, I like computers and I'm interested in studying that at university, but you don't know if maybe the web development that Leticia was talking about sounded cool, but then maybe also AI sounds kind of cool, and you don't know for sure which one you want to do. Getting a computing science degree will definitely help you figure out which one of those you might like more, and then give you the tool sets you need to actually pursue one of those fields.
Anything else to add? Okay, I guess we'll move on then. So then why did you choose to study computer science as PhD student? Kristen, do you want to go first?
Okay, I guess I will go first. For me, I think my main driving factor is there are things that we don't know, right? And I want to know the answer. As I mentioned before, I do research in video games. So basically, what I end up doing is using AI to try to create a better player experience. Right? We've already game and we're like, yeah, that escort mission really sucked, and I wish I didn't have to do that. But you just have to finish the game. So you can use AI as a tool to maybe avoid experiences that people might enjoy less because they're like, I don't really want to do this, but I have to because the game told me to, that kind of thing. So for me, it was like, I want to know the answer, like why do we end up making games that people don't like but then they're still extremely popular, like, so it's just a bunch of questions of that I needed to know, and since there wasn't an answer beforehand, that means I need to go research and find the answer.
Then, I'm sorry, I can't pronounce your name.
Oh, it's certainly. Yeah, that's really cool, Kristen. I had no idea what computer science was when I was in high school, but I really like math and physics. And so I was like, yeah, I guess I'll do that. It sounds similar to stuff that I like. But in the end, it was really nice. I ended up with this like a similar field as Christians. Like I want to help people learn languages. That's what I'm working on right now. But yeah, you can do so much with computer science. Like I learned that later on, of course. But yeah, you can pretty much work on any problem and try to get computers to help you with that.
Okay, Chris, do you want to go? Do you have anything to add?
Sure. Yeah, I guess I definitely agree with Leticia about the like breadth of things that you can do. Like I wasn't really sure what I wanted to do, especially in high school. So it was kind of appealing in that way. And then when I was kind of working between undergrad and grad school, I was sort of like I wasn't learning as fast as I was before, and I kind of wanted to learn a lot again. And so I went back to grad school, and I've really enjoyed that. So just being able to choose what questions I want to think about and try to answer them is really nice and fulfilling.
And someone asked, how many years of computer science do you need in college for you to be set? Yeah, I'm not really sure what they mean. Maybe if like the person who asked that is here, they would like to clarify maybe? Okay, I guess we're gonna go on your guys's I guess what you guys think about the question.
I mean, I guess it's just however long it takes you to finish a degree. I think, correct me if I'm wrong, Chris, but I think the U of A ones are 4 to 5 years for the computing science degree.
Yeah, it's 5 years if you do an internship, which I definitely recommend.
Okay.
But I'll also add, like, it depends what they really depends what they mean by set. Like, I mean, technically, a lot of, if you just want a job in like programming or something, you technically don't need a degree in computing science. So if you're like a really self-motivated person, you can be set, like, whatever the definition of that is, by just kind of learning the material without necessarily spending X amount of years in computing science.
Okay, then I guess this is subjective too, but how much computer languages is needed to be learned?
I can take that.
I would argue that's not a number of language. It's like the concepts that are underlying all of these languages that all of us know are the same, pretty much. So maybe Leticia, you wanna add?
Yeah, that's pretty much it. Like once you learn one of them or just the logic behind it, it gets so much easier to like learn a lot of new ones. I don't know. I had that experience. I don't know if you guys had it too. But yeah, once you understand how it all is supposed to work, like I said, the logic behind it, yeah, it's not about a number.
Okay, so I guess this is kind of related, but how much computer languages no what computer languages do they teach in college?
So if you go to University of Alberta, start by learning Python, which is kind of supposed to be easier to learn. It's like high level, kind of looking a little bit like English, but it's kind of, its performance is not necessarily the best. So later on, you'll learn C or C++, and when you talk about operating systems and stuff, that will be kind of important. And yeah, after that, it's kind of all depends on what your interests are, because usually you pick languages that are sort of tailored to whatever kind of task you're trying to accomplish.
Okay, anything else? No? Okay, then how do you guys deal with the pressure when it comes to projects and deadlines?
I guess I could take that because I am currently working industry right now, so we have a little bit of a stronger deadline. In grad school, your deadlines are what you make of them, so it's maybe not the most highest pressure environment. Basically, what you do is when you start a project or you get an amount of time to do something, it's really important to plan out all of your tasks. Like, say you want to make a game. So then you say, okay, I need to program movement. I need to program like all of my game mechanics. I need to write my story. I need to draw all of my art. So if you write everything down and say, these are all the things that I need to get done, it can help you track and make sure that you're going to deadline on time, basically. So that's what like all of us as grad students do as well, is just planning out and then keeping track of where you are in that work is really important.
So then, okay. Are there any computer clubs or in Edmonton that you guys know of where high school students can join or learn more about coding and actually like apply to things?
I guess it's not necessarily high school specific, but all of the game jams that I mentioned in my talk are available to anybody. So I know it's not necessarily like you'd have to do game development, and if that's not something you're super interested in, then maybe that is not for you, but that would probably be a good resource.
There's at least two things that I know of. So first is Startup Edmonton, which is going to be more geared towards building stuff. They put on like monthly seminar type things or working sessions where you might learn how to code in a certain language or something like that. And typically they're free for anyone who wants to go. And it's just downtown on 104th Street. I can give a link later or something. And the other thing is there is a high school internship program at science at the University of Alberta where you work for a professor for the summer, and you can actually Kristen and I share a supervisor, and he had a high school student this summer that actually got to publish a paper. So yeah.
Okay, then.
Yeah, can I just add one thing? I think the programs are called WISES and HIP. Both of them, like a lot of profs in science department welcome students, high school students during the summers through these two programs.
Okay, then what are the different branches of computer engineering, and what do each do? And how much of it does it involve software and how much involves hardware? Can anyone answer that question?
Chris, do you know what they're talking about?
I have no idea how to answer that question. I'm sorry. Yeah, I'm not even gonna try.
Maybe the issue is that none of us are computer engineers. We're all computing scientists or computer scientists, as we say in the States. So I don't know if we're super qualified to answer that.
Okay. Then how did you become interested in researching topics within the computer science industry? And what's the best thing about your job?
I guess I can go first really quick. I started doing video game development as a hobby when I was in undergrad by doing these game jams that I keep talking about. And sometimes a course would require a project, so I would make a game instead of doing something else. And it just kind of got to the point where I wanted to think more deeply about games. So instead of just saying, oh, I enjoyed this game, it was fun for me to do, I wanted this, and what is interesting about this, and all these other kinds of things. So kind of just became the natural thing for me to study. And I think that the best part about being a graduate student is I think the flexibility to get to pick what you work on, that like my other two grad students will probably agree. And if you go into industry, you have to work on their software package. You have to work on their whatever it is. So you don't get to necessarily say, hey, maybe this is really interesting to me and I want to work on it. So that's, I think, one of the good things about being a grad student.
Yeah. You can go next. I think you kind of think a lot about, like, you choose a research topic, a problem, and you are trying to solve it somehow. And then, as happened to Kristen, like, no one had solved it before, so she's trying to do it. And I think you get a lot of that through classes. So let's say you take, I don't know, an AI class, and then you really like the subject, and then you get to like talk to the professor about it, and then you start thinking about the problems that you were exposed to. At least that's what happened to me. And the best thing about it, I feel like, apart from the freedom of like choosing what you want to do, is being exposed to so many different things. Like, the three of us are friends, but we don't work on things that are related. And we get to learn a lot about what everyone else is working on and what everyone else is finding out.
Yeah, I don't really have anything to add. I think that's pretty much exactly what I would have said. So.
Okay, then this is a question more directed towards Kristen and Chris. So, relationships between computer science and AI.
Yeah, so I think computing science has other very interesting topics that you might want to study, like just programming languages or operating systems or how to solve other problems exactly. But AI is like one field where you will want to take a lot of things that are studied in computing science and applied a certain way. I think AI might be kind of its own field as well, but I think a lot of the skill set is the same.
Yeah, I mean, I would just agree with Chris there. I don't have anything to add.
Okay, then I'm not sure if you guys would know about this, but to apply for a computer science, does someone need to choose some computer science courses in high school?
Definitely not. I didn't do anything related to computing science. I had no idea how anything worked until I was already in undergrad. So there's no need.
Okay.
But it helps. Sorry, but it definitely helps if you know stuff when you go in. Not to discourage anyone from learning.
Then how financially stable are the careers in this field? What do you guys know about this?
I guess it, like, I don't know, none of us can predict the future, right? Like, who knows what will happen in the future. I don't know if you have a better idea than that, Chris.
No, yeah, I mean, there's a lot of jobs right now, but it's hard to say what's going to happen. I think, like, obviously there's going to be programming jobs for a while now, but there might also be like a lot of programmers, so it's hard to say.
Okay, so this person is asking, if I don't know how to code, but I take a few online courses. Oh, you guys already answered this question. I'll just say it anyways. Okay, so if the person doesn't know how to code, but they take a few online courses, can they go into software engineering or computer science? And you guys already answered it. Okay. What is the most challenging aspect of your degree?
It varies by person. I have to say I like math, but it takes me a very, very long time to understand things. I've taken classes with Chris, and sometimes he just intuits something immediately. Is like, yes, this is all the math, and I have to stare at it for like 4 hours before I get them all of understanding. So even though I enjoy the math part and the rigor of my degree, it's hard for me, I have to say.
I think the hardest part for me is, as we are working on research, is not knowing if it's actually going to work out. You're researching it, so it might not work. And yeah, that's really hard.
Yeah, I totally. It's like Kristen was saying, it's easy to manage. It's easier to manage stress if you have a plan. But then when you're doing research, it's hard to have a plan more than a few steps ahead because you kind of have to start assuming things are going to work out or not, and it's really hard to predict sometimes.
Is there a sector of industry that you wish to pursue after post-secondary?
Yeah, I see myself wanting to do like kind of AI research in industry, like kind of pure AI research in industry. So there's a couple of companies like Google DeepMind and OpenAI, and even some other local places like Borealis that are doing kind of just AI research for AI research's sake, and like actually inform people to do that. So that's kind of where I want to go, but we'll see.
I mean, for me, it is a little bit obvious as I already work in the industry, but actually my goal right now is to go be a professor. So if you're doing a graduate degree, it doesn't mean you have to go into industry. Professor is also equally valid job.
I don't have a really good. I'm just gonna see what happens.
That is very valid. I guess then how are jobs looking in like someone is considering pursuing it in life, but they're wondering if there's actually good opportunities available. And they're also asking if it's viable to start your own business in the tech industry and how you would go about it.
Chris, you have the startup experience. You get this one.
God. Okay. Yes, there's definitely. I mean, if you work hard and you're like, you learn the material that you need to learn, you'll get a job for sure. I definitely believe that. Okay, and then starting basically having a startup, like that's a whole nother story, right? Like that depends on a lot of things. You have to have you have to do market research and sort of figure out, for your specific idea, is it possible that it could work? And then you have to, build a thing which has its own challenges that you would be actually prepared for if you took a computing science degree. But there's like a whole things that are related to like businesses and markets that I'm not at all informed about. So it's hard to say. Like you could do it, yes, but I don't know.
Yeah, I think for people who are interested in that, is Startup Edmonton has a 101 business model course that might provide you like with more answers than we can. At least I think.
Okay, I guess moving on then. Do you think the tech industry will become like oversaturated like some other fields, like engineering maybe?
Again, we can't predict the future, so maybe this would just be us speculating. I personally think that that's not likely to happen as we continue on in like the journey of humanity. We're constantly requiring more and more technologies and being applied in places that weren't before. So, every single app that's ever been created also needs a maintenance team behind it. So there's a lot of stuff that just constantly being needed to develop, maintain all these other stuff. So I don't see it really going away, if that makes sense.
I will say that there are a few things that are sort of unsustainable in the tech industry right now. Like some of the funding that startups are getting aren't really matching like what they're providing to the world. So there's some stuff that could happen that could make it a little bit less lucrative than it is now. But like, it's not gonna. I don't think it's gonna be like a huge burst of a bubble or anything.
Anything else? No?
Yeah, I don't have a lot to add.
Okay, then what are some computer and computer-related fields that high school students could consider if they're interested in comp sci or computer engineering?
I guess we can start talking about the three fields that we talked about today. Yeah, so programming, software engineering, software development, that's more related to like actually writing programs most of the time. But then you choose like if you're writing programs for the front end, the back end, or for different type of application, like I don't know, a game engine. What else? So you can work as a researcher on AI or on a different field that involves less programming and more reading about your research problem. What else?
Also, like data analytics pretty much creeps into every field nowadays. So like, you have sports teams, businesses, whatever, basically anybody that has a bunch of data wants to analyze it so they can make better decisions about hiring people or making trades in sports or whatever. Basically, like the people that do that kind of analysis are typically from like, you know, computing or stats or math. It's all kind of related backgrounds.
Okay, I guess I'll move on. So do you think Alberta is one of the like IT bases, like the headquarters in North America? Do you think it's like,
I think it's growing, but I wouldn't. It's at the hub level of some of the places like in the States or even some places in Canada. Like Vancouver, Toronto are big ones for tech in Canada. Then we have Seattle, the entire Bay Area, Chicago, Austin. Like there are a lot of different places that are tech hubs, and Edmonton is just starting on journey, I think. So there are jobs here that do tech. Like don't get me wrong, just maybe not as big as some of these other places.
For like specific subfields, though, there's definitely some stuff in Edmonton that you can't get anywhere else. Like for certain subfields of AI, we have researchers here that are kind of the founders of them, and so we attract students basically from all over the world, like top students from India, China, and whatever, to come work with these people. So we have one of the strongest AI programs in the world. And then I think there's a couple other fields that also have some similar.
okay, then someone is asking in the recent 1 year, is there a genius from America immigrated to Alberta? And how do you think the Alberta environment is for startup entrepreneurs?
I'm from America. I don't know how many people from America are at the U of A. I don't think there's a whole lot of us, but I mean, that's just from me being in the department and meeting people. So I guess I don't know. I don't know if I necessarily say like there's a bunch of computer geniuses in America specifically either, right? Smart people are all around the world. So
Okay, then what are some things high school students can do to build up their applications for college and university? Could like anyone?
Yeah.
So I mean, if you can do it, the internship thing is definitely like the biggest boost for any application into comp sci. And then once you're in comp sci, like, and if you want to go into industry or anything, doing an internship there is also a good idea. Like internships are really good. Otherwise, just I think you just get in if you have good marks. So if you guys are interested in it, you probably already know that. But
Okay, then I guess more directed towards the females here. How do you guys cope with diversity imbalances in STEM, and how's it affected you?
I guess I will start, and then Leticia, you get to answer after me. I think that it's not always easy, but anything worth doing in life is going to be a challenge, going to be a little bit difficult. And just because it's a little bit scary, sometimes doesn't mean that everyone like in the department is out to get you, is going to be super mean and all this other stuff. Things are changing really, really fast. Even from just 5 years ago started, or 7 years ago when I started my undergraduate degree, things are completely different. So I don't think it's something to be worried about not entering computing science or a STEM field because of it. It's just know times are changing and things will get better.
Yeah, I agree with everything that Kristen said. Like, has been changing really fast, and like it does get hard sometimes, but there are a lot of nice people. Like you get to meet a lot of nice people, and they help you a lot. So yeah, it's definitely not something like you should not do computer science or any science because of that, because there are going to be hardships, but you're going to meet so many good people that's going to be worth it.
Then I guess according to you guys, what are some of the most prospective topics in comp sci?
I mean, I guess AI is the big one. I know it's the one that's on everyone. So it seems like everybody now is talking about their new AI. Like every industry has AI to do that kind of stuff. So I mean, Chris and I both do research in AI, so it'd be hard for us to say that it's not an interesting field to work in.
Yeah, in addition, I think there's a lot of opportunity to study like smarter kind of code generation or systems and stuff so that people can do, AI algorithms can run faster, because right now a big problem in AI getting the scalability with the amount of hardware and running algorithms for long enough to get like results, basically to train the AI so that it's smart enough. It takes a really, really long time sometimes. If we can improve hardware stuff and scalability, then that should go a long way.
I think one thing that's kind of related to AI, but kind of different, is data analysis. So we are producing a lot of data right now, we as humans, and we get to discover a lot from that data. And it's kind of related to AI, but it's a whole different field.
So if you guys have nothing else to add, that's the end of the questions that have been sent. So if anyone just wants to directly ask any of the PhD students, like in the chat or by microphone, you're welcome to. Okay, so the question is there any specific way in which you start learning RPG Maker or Unity to learn about it?
I guess this one is for me. So I will caveat this. I don't know if I remember to say this in my speech. Unity and Unreal have free student licenses, so you can download that program on your computer today and start working with it. RPG Maker, unfortunately, does require a paid license. Normally, it's $80. However, multiple times a year, it goes on sale for like 15. Like I'm talking 5 or 6 times a year. So please do not buy it. If you're interested in like buying the software, please don't buy it at full price. Please wait for it to go on sale. It goes on sale on Steam and Humble Bundles like every so often. Um, Honestly, the way that I would start trying to use these programs is to try to make a game, right? Like say like try and make a Mario clone. Learn how to do the like movement mechanics and jumping mechanics, and all of the resources that you need to actually build those things are available online. There are tons of YouTube tutorials. Unity has their own suite of tutorials that are available. RPG Maker has their own tutorials and stuff like that. So um, just try it, and you'd be surprised at what you can learn.
Yeah, there's another question, which is, my computer's pretty weak, but what types of programming software can run on it? They have a 32-bit 4 GB RAM.
The good thing about programming is you can write small programs at first, and you don't need a lot of software to write programs. Like you just need a thing called a text editor, which is usually really small, and then you can typically can run them. Like if you're on Windows, then you might want to use something like Visual Studio, because the build, like compiling, which you'll learn about, is a little bit more complicated. But if you have Mac or Linux, it's really, really not demanding for hardware.
Yeah, Python might be a good place to start. Python is super lightweight, and you can just use a text editor. And even on Windows, I just use a text editor for my Python. So.
Okay, another question came through. I don't think you guys can see it, but it's there's some pretty hot topics these years in comp sci, like comp sci, software engineering, AI, big data. Are there any concerns, comments about IT network bubbles? It happened before. Okay. Here, I'll post the question publicly so everyone can see.
I mean, I am definitely not a networking or IT specialist, but I do know that if you do not have good IT and networking, everything breaks. So I'm not sure if we have to be too concerned about it, right? If your networking is basically the internet, if your internet breaks, you notice. So there's a lot of support and stuff that has to go into that.
I'm not sure what. So is the question asking about like bubbles, like in terms of like the market, or I don't really know what IT.
Does the person want to come and clarify? Okay. Okay. Maybe post it to everyone instead of like privately messaging me. So that's.
Oh, okay. So yeah, it is about the job. Yeah. So yeah, I think it's a valid concern to have. Like something will probably happen. I'm not worried because, like, you know, if you learn that, I think if you learn the concept and the material well, like you'll kind of a person that has very good job security.
Okay, then sub to, I'm not gonna say that, okay. They asked, would you say that Lua, I'm sorry, is a good programming language? Because they only know Lua and a bit of JavaScript and Python.
I don't know Lua. Do you guys know Lua?
I heard about Lua during my undergrad. I remember a group in my university, they used Lua to program smart TVs. Is that the same Lua? I don't know. But I think, as we said, any programming language is valid because you learn the logic with it. You learn the programming logic with it. That's applicable to all programming languages, basically. So yeah, if you know Lua, yeah, keep working on it.
So does anyone else have any questions? I guess we'll wait a little longer just in case. If otherwise, we'll close up this webinar. I guess we'll wait till like 3:15. Anyone with questions can just fire them in the chat. So, oh, okay. Someone asked you guys did for undergrad.
Yeah, so I did my undergrad here at the University of Alberta, and I did computing science honors, I guess, which is very like flexible program, which I took a lot of computing science and math options in addition to the like core pad, which is kind of, I think the information is on the website, so I'll grab a link right now.
I have a little bit of a unique path into computer science. So In my undergrad, I have a degree in biochemistry and molecular biology, but I decided I didn't like it anymore. So I went and got a master's in computer science, and now I do computer science for my PhD. So it's never too late to decide you want to switch, and you would be interested in something else.
Yep, and I did my undergrad in Brazil, where I'm from, and I did computer science as well. Yeah, that's it.
Any more questions? Oh, I would like to ask. Wait. Oh,
Sorry. No, I thought you were asking. Sorry, I thought no one was asking a question. Okay, you can ask.
Oh, no, wait. Are you gonna ask a question?
No, I was just gonna like end it because I thought no one was asking a question. But was someone gonna ask a question?
Oh, can I ask a question?
Yeah, go and ask a question.
Then, I'm not sure, but is there a difference between honor programs at the U of A for comp sci and like normal, or is there even like a normal, I don't know, is there like normal degrees in comp sci besides honors?
Yeah, so the way it works is I think typically most students are enrolled in like a specialization program or honors. And then the specializations are kind of like, you want to take more business courses, or you want to take some kind of like biology courses and you want to do bioinformatics or something. So it kind of depends on what you plan to do. But the honors program is the most flexible, I would say, because there's the least amount of like required core courses and there's just more like options, I think. But you have to maintain a certain GPA. So the other thing is you can just, as with every other, like at this university, this is all specific to this university, but at the University of Alberta, you can pretty much in any science, you can just choose computing science as your major, for instance, and then any minor, and there'll be like some set of requirements. You just have to kind of, it'll be kind of on the same website that I posted just for the specifics.
Okay, I don't think there's gonna be any more questions. So do you want to close it off then?
Yeah, thank you guys so much. Like, we really appreciate it. Everyone learned so much.
We're happy to come and talk.
Yeah,
I'm honestly shocked at how many people came too.
Yeah, thanks for organizing it and moderating it. That was really good.
Thank you so much. Oh, is it okay if we post the video of this seminar to our website?
Yeah, I'm okay with that.
Okay with that?
Yep.
Okay, thank you so much. Okay, I'll stop.
Yeah,